In our last tutorial, we will solve right triangles. So now we are ready for our ultimate goal, solving right triangles. Thank you for watching the tutorial on side lengths, and thank you for watching the tutorial on angle measures. Now we will solve right triangles, and what it means to solve a right triangle, we must find all 6 measures. What that means is all 3 sides and all 3 angles. Now, of course, I need to give you some of that information before you can even start to solve. In fact, I will always give you 3 pieces of information, and you'll be looking for the other 3. So the direction says to solve the following right triangles, and of course, we will continue to round to the nearest thousandth, or 3 decimal places. So in this example 9, we have a right triangle, so that's one of the angles, and I gave you 2 of the side lengths. So you can see I've given you 3 of the pieces of information. We're just looking for the other 3. Let's find the missing side length first. This is angle X, so opposite it should be side X. Let's talk about side X. Since I have 2 sides of a right triangle, I can use Pythagorean theorem. I always start with my hypotenuse, 16 squared, and that will be equal to x squared plus 14 squared. 16 squared is 256. X squared, of course, is x squared. 14 squared is 196. Let's solve for x squared first. Subtract 196. And I'll bring my x squared over here. X squared is equal to 60. And of course, now I need to take the square root. And I've got x is, now it says that I can round my answers, so I can just plug this right into the calculator and get an approximate for the square root of 60. And I will do my square root of 60, and I get approximately 7.745, but the 9 is going to put that 5 up to a 6. 7.746. 7.746. That's my missing side. And I'm finished with sides. Now I really don't want to use this side length anymore unless I store this whole thing into the calculator. So I'm going to continue to just use the 14 and the 16 since those are nicer values. I need my 2 missing acute angles. I'm going to choose this time to stand here. I need to choose one of the acute angles to stand. I'm going to stand on angle Y. I still have my SO, CA, TOA, and if I'm standing on angle Y, I'm given the opposite side and the hypotenuse. Opposite and hypotenuse is my sine. So I'm going to set up an equation using my sine ratio. This is angle Y that I'm looking for, and the sine is 14 divided by 16. I know that this reduces, but that doesn't really matter. My calculator will handle it. I'm looking for angle Y, so the measure of angle Y is equal to, I need to get rid of the sine, so I do inverse sine of my 14/16. Measure of angle Y is going to be approximately whatever this says in our calculator, and let's see what that is. Inverse sine, second sine, 14/16. And it looks like our angle is 61.044, but the 9 will bring that 4 up to a 5. 61.045 degrees. 61.045 degrees. I'm pretty much finished. I have one of my acute angles, and here it is. The other one will simply be 90 degrees minus that. So that's not that much work. I can do that in my head. 61 from 90 will give me 28.955. Maybe I shouldn't try to do that in my head. Maybe I should check that on the calculator. Let's do 90 minus my previous answer, and I get 28.955. It's always good to double check. So we solved this triangle. I gave you 3 pieces of information, and you found the other 3 pieces of information. All right. Last example. We have 2 angles given, 90 degrees and 57 degrees, and only one side length. So I think it's easiest to find the missing angle. 57 plus what will equal to 90 degrees, and that will be 33 degrees. So we can come off and say, okay, the measure of angle B is equal to 33 degrees. Not approximate, it is equal. So we have all three all 3 angle measures. Now we're missing sides. This is side A because it's opposite angle A. Angle B would be opposite side B, so I'll put a little B right here. And angle C would be opposite side C. That's how you label your triangle. And we need to find those sides. I'm going to choose to stand right here at angle A because that was the acute angle that was given. And if I'm standing here at angle A, I have the opposite side. Opposite uses sine and tangent. So I'm going to first talk about the sine. Sine of 57 degrees. The sine of my 57 degree angle would be the opposite 15 divided by hypotenuse C. And there's my equation. I'm going to put this side over 1, and I'm going to do my cross multiply. This diagonal, this numerator, times this denominator, C times the sine of 57 degrees, will be equal to the other diagonal product, 1 times 15. Let's divide that sine of 57 degrees away. And I'll have C is approximately, well, whatever that says in the calculator. 15 divided by the sine of 57 degrees. And this side length is 17.885. 17.885. It's a side length. It is not an angle. Do not put degrees. One more side length to go. I could use Pythagorean theorem to find it, but then I'd have to have this stored in my calculator, the entire thing. So I'd rather not do that. I'm still standing right here at the 57 degree angle. Opposite divided by adjacent would be my tangent. So I'm going to set up a tangent equation. The tangent of my 57 degree angle will be opposite 15 divided by b. Put this over 1 so I can do my cross multiply. B times the tangent of 57 degrees is equal to 1 times 15. I'm running a little bit out of room here. Let's divide the tangent of 57 degrees away. And I'll put it right up here. B is going to be approximately 15 divided by the tangent of 57 degrees, and we've got it, 9.741. 9.741. And we solved this triangle. We had these 3 measures given, and we found the missing 3 measures. That's what it is to solve right triangles, and you're using a lot of trigonometry to do that. Thanks for watching these tutorials, and we will practice this in class. Bye-bye.